Hello everyone, I'm back with my next lesson. So in this video we have inverse of 3 by 3 and I'm going to show you an example on that. So the example I have is it's 2, 3, negative 1, negative 1, 0, 4, 0, 1, and 1. Alright. Idea still the same. So pretty much you have to have determinant and adjoint matrix. All right. Okay, so what I would do is there's a recommendation I would like to talk about first. So remember, if the determinant is 0, so what happens is at the end there will be no inverse. Something you could do first, you can find the determinant first by picking any row and multiply by their minors. Because let's say if you did the whole process and at the end determinant 0, then there's no point of spending 20 minutes doing that. So it's easier if you find the determinant first, and if that becomes 0 right away, just say no inverse. If it's different than 0, then it's kind of like worth it going on and then moving on and finishing the whole problem. So since I already know determinant is not 0 for this problem, so I'm actually going to start off with minor. So let's do that. So first of all, I'll start off with minor matrix. Okay, so let me pick a different color. So let's pick light blue. All right. So I have, oh gosh, yeah, that's good. Perfect. So I need to start off with its minor matrix. So I'm not going to do all for you. So I'm just going to pick one element from each row because there's no point of spending 10 minutes just finding matrix. And you know, my minor matrix is the only time consuming, only part where it's going to take a lot of our time. Rest is pretty much playing with those numbers. Okay, so let's say if I'm looking for minor for this number, so I would cover this entire row and this column. So what I have is I have 0, 4, 1, 1 left, and I'll find the determinant. So I would replace this number with the minor of that. So 0 times 1, 0 minus 4 is negative 4. So I already have rest of these minor numbers written down here. So I'm just going to copy those. Negative 1, negative 1. I already have 4 for this one. I'll show you this one from second row. Again, I would cover this entire row, this column here. So I see 2, negative 1, 0, and 1. Find the determinant. It would be 2 times 1 is 2 minus 0, it's 2. Then I have negative 2. Then I have 12 here, 7, and I'll show you one more. This one here. So cover this row and this column here. So once I have that, so I have 2, 3, negative 1, 0 left. Multiply, so 2 times 0, 0. Minus negative 3 would be plus 3, positive 3. Done with my first step. Next one, finding cofactor matrix. This is where you apply the sign pattern. So let's put a negative, plus, minus, plus, minus, plus. Oop, my bad. Okay, so it's minus, plus, minus, and plus. So basically multiplying every single minor by the sign. So negative and positive would become negative 4, then 2 negatives would be 1 positive, negative 1, negative 4, 2, positive 2, 12. Here you go. Next one, finding its adjoint. So basically, it's just interchanging rows with columns. So every single row would become my column in my adjoint matrix. Okay, so this whole row would be my column. Now the second row would become second column. Third row would become third column in this adjoint matrix. Let me double check I did everything right. Negative 4, negative 4, 12, 1, 2, negative 7, negative 1, negative 2. This is negative 2. Why it's negative 2? I guess I messed up on, this is positive 2. Oh, my bad. This is positive 2. My bad. I messed up. This is positive 2. So that's the reason this would be negative 2 here. And this is also negative 2. Okay, anyways, I have my adjoint matrix. Now, time to find the determinant. This is where we multiply original row by its minor. So first you got to pick a row. So I hope you remember we picked the row that has maximum number of zeros. So I have 2 different options. Either I could pick second one or I could pick the third one. Now there's another thing you could do. So if you want to take second row, you can multiply by its minor. If you multiply by the minor, you have to follow the sign pattern. But think about it. Isn't a cofactor matrix already has sign applied to it? So how about if I take my original row and multiply by cofactor numbers and add them all? Because I already applied the sign pattern in the second step, right? It's going to be the same thing. So whichever way makes sense or it's easier for you, just do that. But don't forget, if you take minors, follow the sign pattern. If you take cofactors, just add them all, all right? So I'm just going to take cofactor. It's easier, trust me. So let's say if I take third row, I have 0, 1, 1. So 0, 1, 1. I'm gonna take my cofactor so I don't have to follow any sign pattern. So 1's going to get multiplied by 12. I'm sorry, 0 by 12, 1 by negative 7, 1 by 3, and I would just add them all. Multiply 0, so negative 7 plus 3. Simplify, so my determinant is negative 4. Almost there. So I have 1 over determinant, which is 1 over negative 4. My adjoint matrix, which is negative 4, 12, 1, 2, negative 7, negative 1, negative 2, 3. Simplify. It's basically every single number divided by negative 4. So negative 4 divided by negative 4, 1, 1, negative 3. Negative 1/4 or negative 0.25, either ways. Positive 1.75. Negative 1 divided by negative 4 is positive 0.25. Positive 0.5, negative 0.75. Here you go. So that's my inverse of this 3 by 3 matrix. Thank you guys. Thank you for watching. Bye-bye. Stay safe.